All right, so if we want the tangent line and the normal line. Now, I'm going to just throw in another little butt-chewing moment. If you can't write the equation of a tangent line at this point in the course, you've got a lot of catching up to do, okay? So let's just back all the way up to Algebra 1. If I want to write the equation of a line, what two pieces of information do I need? The slope and a point, okay? Where do I get the point? Well, here, I get it from the problem, right? But let's just say they said at x equals 1 and they didn't tell me 0. You have to plug it in and get your y, right? All right, so that would give me my point. Plug it in. Plug it into where? The equation, the original function, right? Okay? And then if I want my slope, find the derivative, okay? All right, so I need my derivative. I'm going to go ahead and start using the prime notation pretty exclusively. And it would make some of your work on the implicit problems easier and cleaner. And I mentioned when we were going over the notes that you could do that, but I haven't seen much evidence of many people taking advantage of that option. All right, so when I go to take the derivative of this, first of all, how do I know it's implicit? Because what? Yeah, there's a y on both sides. The x's and y's are commingling, all right? Now, if I had, say, plus y on the other side, then technically I could subtract that away. But when it's mixed into a function where I can't just easily extract it or solve for y, that's your sign, okay? All right, so no pun intended, Trace. Okay, what's the first thing I should do to this in taking its derivative? Sine. Got it, Aaron? Aaron furrowed brows, looks at Trace like, here, please explain to me what you just said. Hello? Pull out the 2. Why? Because it's a constant. So once I pull it out, I forget about it. I just let it sit there. Now, I don't forget about it in the sense that I don't carry it to the next line. I just don't have to think about it anymore, right? That's the beauty of pulling it out. So what am I really taking the derivative of? Sine of the pi x minus y, right? Okay. So this is a chain rule problem because this is a composite function, right? So take the derivative of the outside first. The outside is cosine. I'm sorry, is sine, and its derivative is cosine, right? So I'm going to put cosine, and then what do I put? I keep the inside the same. So that's real easy. I just copy it, right? Then what? Time the derivative inside. I must have parentheses. And we're getting better about that, but I still saw one instance in the, I've started grading the quiz already, and I saw one instance where parentheses were left out where it actually mattered. And it often does, or I wouldn't make a big deal about it. What does this go? Pi. Why do I put, all I need is pi there? Because it's pi x, right? So I do everything normally when it's an x term, right? Minus y prime. Okay? Now, I could clean that up, rearrange some stuff, but I don't really care what that says because I'm writing a tangent line here. And then I'm going to write a normal line, right? Okay? So I'm going to get my y prime at 1, 0. Right? So I'm just going to plug in a 1 everywhere I see an x and a 0 everywhere I see a y.
Don't you have to keep cleaning up because you have a y prime?
Oh, yeah, we didn't get y prime by itself. I'm sorry, I'm trying to read faces and... Okay. No, you're not going to divide that because that would not work.
Distribute.
You have to distribute. So y prime equals 2 cosine. But the point I make was you don't have to clean up if you didn't have a y prime on both sides. Once you get your y prime, if you're writing your tangent line, I'm not going to take off because you didn't simplify or clean up your derivative, okay? And I don't know that I've said that much. That was why I got myself sidetracked there. All right, but here, so the first thing, I'm actually distributing this whole thing, right? And I know that's kind of ugly and clunky, but it makes more sense. So it's times pi, and then minus the whole same thing. So 2 cosine pi x minus y prime. This is what?
When she was explaining one of the numbers to us yesterday.
They thought you had to put like the pi to like the cosine.
Oh, when you were explaining to them? Oh, yeah. Well, and that's like I keep telling y'all, when you're confused about whether the multiplier multiplies each piece, what are you doing? If you're multiplying them all, that's like 2 times 3 times 4. If I multiply 2 times 3 and 2 times 4, I get a different product, right? So that's how you keep it straight. All right, so now I'm going to get my My y prime terms on the same side? That's a pi. Minus y prime equals 2 cosine pi x minus y. And that's it, right? No, times pi. That should be a 2 pi. I'll put the pi with the 2. Because my brain will tell me I did if I didn't, and then it'll mess me up. There we go. Is that right now? Okay. So, now I need to do what? Pull out the y prime. I get y prime equals 1 plus 2 cosine pi x minus y. Why did I put equals? Oh my God, why did I put the equal sign there? I need a break. All right. Yeah, that's it. Let me just move that over so it's actually where it ought to be. I don't know why I put the equal there. All right, I was looking up to see. Did I get everything? Yeah. All right, so equals the same side. That's a minus. It doesn't look like a minus, but it's a minus y. There we go. All right, so my y prime is, and I'm writing huge because suddenly my screen got resized on me. Here we go. Y prime equals 2 pi. Come on, board, you can do it. It was the lag. It did it after I said that, so maybe it just needed to be talked to. Cosine pi x minus y over 1 plus 2. Oh my God, stop it. I told you I should have cleaned my screen. 2 cosine pi x minus y. Oh my God, there we go. Yes? All right, so what are we going to do now? We're going to plug in our given values. I'll use this ratty one up here. All right, so do that right quick. Tell me what you get. And I feel compelled to reiterate, because I think one child at a time I will change the world. When I do these problems with you, you should not write them on your homework. You should write them on separate paper. Then you should hide that paper from yourself and go finish your homework. That's how you hold yourself accountable for actually learning what we're going over. All right, so what do we get for our y prime at the given point? 2 pi? Okay. So your computations said that it's 1.10, right? 10 is 2 pi. Yes?
Yeah.
So what's our tangent line? Equals 2 pi times x minus 1. And if it bothers you, since you've already got y by itself because y was 0, and you want to go ahead and distribute the 2 pi, that's okay, but you don't have to. All right, so there's my tangent line. So that's my answer to A. And my answer to B, which was the normal line, got it?
Yeah.
All right, 27. I already know what's wrong with 27. I will bet. I'm going to bet this now, and then whoever asked for it can tell me I was wrong at the end, because I really want to know. All right, well, first of all, you should know this animal when you see it. Circle. Radius 1, centered at the origin. Now that's helpful because if I'm trying to picture the problem in my head, because one of the things that tends to bother students on this section is that when it asks you for the points where your tangent line is vertical. Why would that bother you? Probably because it's hard to think about the fact that something might have 2 vertical tangents or 2 horizontal tangents at the same x value, because these are relations. They're not functions when you have the x's and y's all. Not always, but a lot of times. Now, and this one obviously is not a function, and that should help reinforce that whole notion that the rules you're used to thinking about don't really apply here. All right, so we're simply finding the first and second derivatives. All right? So we'll start with our first derivative. And what would that start with? 2x plus 2y, y prime, equals 0. Okay? So I'm going to divide through by 2. And I'm not going to have a 2 because I just divided through by it. And I've got y prime equals negative x. See what I did there? And then I'm going to divide by y and get negative x over y as my first derivative. Yes? So there's the first part of my job done, but now I have to take the derivative of that. Okay? Now, there's a variety of ways you could do this. I'm going to use the quotient rule just because. Or would you rather use a product? Okay, let's show of hands. Quotient, product. We're going with quotient. All right, we should end up in the same place, right? All right, so I'm going to take the derivative of negative x over y. So this is now my second derivative, d2y over dx2. All right, and I'm kind of squeezing it up here to make sure I have plenty of room. Equals. Actually, I'm not going to have room for the quotient rule if I do it up there. Let me just move it down just a hair. Go a little bit further. Okay, here we go. Oh, it's going really tiny, isn't it? It resized me again. And if you're interested, I'll show you why this is so crazy and why some days I just don't feel up to it. All right. Tell me about the quotient rule. How does it work? The bottom squared on the bottom. Okay? So I'm going to write y squared on the bottom because there's y on the bottom. Yes? And then lead with the bottom on the top. And if you don't do this, you will screw up because the numerator has a difference in it. And I can't subtract in any order I want to unless I'm okay with getting the wrong answer. All right? So I led with the bottom on the top. So what does that mean has to follow it? The derivative of the top, which is negative 1. Right? Minus y prime times negative x, which is going to make this now plus, right? So this is technically, not technically, this is equal to negative y plus x y prime over y squared. But it's bad form to leave the y prime as a definition of my second derivative. Because I don't want my, my derivative is already dependent on x and y. I don't want to make a third substitution necessary, right? So what am I going to do about that? I'm going to go ahead and rewrite this as 1 over y squared because what I'm about to do is going to get messy if I don't. And then negative y plus x times negative x over y. Right? And then I get 1 over y squared times negative y minus x squared over y. Yes? And then I could go distribute my y squared, and I get negative y over y squared minus x squared over y cubed. Yes? And if I needed to get a common denominator or wanted to, I would have negative y squared minus x squared over y cubed, wouldn't I? Are you with me? All right. Well, I'm going to go one more step just because it bothers me when there's something I can factor out. And this habit will also make problems like this much simpler. I want to get that negative out of there, so I'm going to say, well, that's just the negative of x squared plus y squared over y cubed. What is x squared plus y squared? 1. So this equals negative 1 over y cubed. Yes, because the problem said that x squared plus y squared is just 1. I bet that's where you made your error, wasn't it? You didn't substitute. Oh, did you? Oh, the very last step? Yeah. That's what I meant. Because presumably you think you're in really great shape till you go to check your answer. You're like, what? Where did x squared plus y squared go? All right. And remember, and that was why I kind of threw that hint out there that you're going to have substitutions involved, and that when you see that happen, check that. So that was 27. We still have 57 and 62. Y'all just didn't really want to do 4-3 today, did you? All right, 52. 57. Oh my God, y'all really? I feel like I did this with like 47 people, so I don't know why anybody doesn't know how to do it yet. Or maybe it was just like 4 to 7 people. Probably more along the lines of 4. Find the normals to the curve. Now, it is crucial, particularly when you get to this part of the assignment where it starts, instead of just throwing something at you and telling you to take the derivative, there's a sentence involved, that you read and understand the sentence. Because if you don't, if you're trying to go too fast, or if you're being lazy and not actually reading and making sure you're clear on what it is you're about to do, you'll do some great calculus with the wrong question. So it's kind of like when I ask y'all a question and you answer the one you wish I'd asked. That's sort of what you're doing, but that doesn't work because that says I'm either a lunatic or a slob. I don't read. Okay? So the line that is normal to the curve at 1, 1, I'm sorry, I'm reading the wrong thing. Find the normals to the curve of this equation that are parallel to the line 2x plus y equals 0. So I want the normals to this curve that are parallel. So I want my normals to be parallel to this line. Okay? So I am given the equation xy plus 2x minus y equals 0. And I am given, so I want the normals parallel to, and you will see parallel to a lot, 2x plus y equals 0. Well, I need to know, if I want it to be parallel to this, that implies a slope, right? Well, this one's really easy to get in slope-intercept form, so let's just do it. I throw the negative, the 2x over and it becomes negative, which tells me I want to know where the m subscript perpendicular equals -2. Why should I write that for myself? So I'll remember that I'm writing the equation of the normal line and not the tangent line. Okay? And putting that m subscript perpendicular is necessary for showing what all the little pieces of gibberish you put on paper mean. Yes?
Wouldn't -2 be the slope and 1/2 be the perpendicular?
No, because it said find the normals to the curve that are parallel to this. So this is m perpendicular means that that's going to be my normal slope. Okay? All right. So, and there's like 3 or 4 different ways to do this. I could just ignore that other line until I found my derivative. But if you do that, you need to go back and reread the problem and make sure you're clear on it. Okay? All right, so I'm going to take the derivative of this. So this is xy prime plus y plus 2 minus y prime equals 0. Yes? Then I need my y primes by themselves, so I keep xy prime minus y prime on this side and throw -2 minus y on the other side. Then I take out my y prime. That's a prime. What? What are you confused by? Okay, well, that's how fast, at this point, y'all should all be going. Right? And that's why if you're writing y prime, it's a lot less clunky if you do the dy dx, which slows you down. Okay? This is a product, so it's a product rule. kept the first, took the rid of the second. Took the rid of the first, kept the second. Derivative that's 2, derivative that's y prime. Right? Yes?
How do we make sure that like our y prime doesn't get confused with like 1 to the first power?
Well, at some point we shouldn't be writing 1 to the first power. And a prime mark is a slant. A 1 is vertical. This is where handwriting becomes a thing. And it's your job to make it clear. And if you're using first powers, which most calculus students don't, beyond the training wheel phase where you're doing that just to remind yourself, if you do, you should probably do it like with the little hook at the top and the platform at the bottom to emphasize that it's a 1, not a prime. Yeah? But if you like DYDX better, keep at it. It drives me a little crazy. All right? I mean, when I'm doing it, I get irritated having to write DYDX every time. So I take out the y prime. You good with me? You with me now, Carlos? Anybody else confused about what just happened? All right, so I'm going to take out the y prime, and I get x minus 1 equals negative 2 minus y, and y prime equals negative 2 plus y, quantity, over x minus 1. And I don't need that parentheses, so I'm not going to use it, over x minus 1. So this is my derivative, which would give me the slope of what? Tangent line. Okay? Now, this is what I was saying about you have choices. Okay? This, I want my normal lines to be parallel to this, right? Which means I want my normal lines to have this slope. So I have a couple of options here. I can either adjust this expression that we just found for the derivative so that it matches this negative 2. Okay, because this is my normal slope, right? So then this is my tangent derivative, right? So what is the relationship between those two slopes? Negative reciprocals. So I can either negate and invert this, because that takes care of that, right? And set it equal to negative 2. Or I can keep this and negate and invert that. You follow me? I think it makes more sense to stick with the negative 2, because we already know that the negative 2 is our slope. And I think if you switch back and forth, it might mess you up. But that's just me. There's not a right or wrong way. It's whatever makes the most sense to you. All right, so I'm going to negate and invert this. So I'm going to put x minus 1 over 2 plus y equals negative 2. Y'all with me? All right, and that was just a decision I made. That's one of those where you have choices. You get to decide whatever makes the most sense to you. All right, so then x minus 1 equals negative 2 times 2 plus y. And then x minus 1 equals negative 4 minus 2y. So x equals negative 3 minus 2y. That's what I'm getting. Agreed? All right, so now I need to know what to do next. What should I do next? Plug it in where? To the original function. So I'm going to replace all the x's with negative 3 minus 2 y's. I could have just as easily solved for y and replaced the y's with the next expression. Okay? All right, so I'm going to go here and I'm going to write negative 3 minus, oh, that's too big. I need to expand my board again. All right, negative 3 minus 2y in parentheses, because all of that is x, times y plus 2x. No, we're doing y's, aren't we? No, we're replacing x's. All right, negative 3 minus 2y. I lost track of what I was doing because I'm zoomed in. Plus negative 3 times minus 2y. And then minus y equals 0. Then I clean up, and I get negative 3y. That's terrible. Let me fix that. Negative 3y minus 2y squared minus 6 minus 4y minus y equals 0. Then I get them all together. So I'm going to pull my negative 2y squared up front because it's my square term, and then I've got a negative 3y minus 4y is negative 7y minus y is minus 8y minus 6 equals 0. Did I get everybody? All right, now I'm going to divide through by -2 because I can. And that gives me plus 4y and plus 3 equals 0. So then this is y plus 1, y plus 3 equals 0. So my normals occur at y equals -1 and y equals -3. So how do I get my x's? You could go back to the original if you're a glutton for punishment, but you'd be much smarter to come back here and get your x coordinates. Go back to the one where you solved one for the other and substitute in here at x equals 3 minus 2y to get your, I'm sorry, -3 minus 2y to get your x's. And then you've got your points, and you already know your slope is -2, so you get your 2 lines, right? And we will start with number 62 tomorrow and then go to 4-3.